Okay, intro to differentials. Just want to keep working. Just it's all kind of based on this thing that we're starting with here. And what I just want to tell you is this. And for now, I just want you to kind of get this. I'm going to keep this video super short. That if we move this stuff around, first thing we're going to do is kind of rename stuff and say that this is equal to y is equal to f of c. Well, this is f of c right here, isn't it? Plus f prime at c x minus c, and what we're saying here is you're given the point c f of c, right? Instead of numerical points that we would take in algebra, we're just doing the same thing, but we're just taking this in a more abstract way. And what I want you to know is that when the change in x, we're going to just call this right here, we're going to call this the change in x, and that makes perfect sense to me because it's the change in distance, isn't it? So change in x there. So what we're going to say is this: when the change in x is small, then the change in y, and this is where we get to something, the change in y can be approximated in this way, is equal to f of c plus change in c minus f of c. And what we're saying here is that this is, and here's the point, this is what you got to take. And if you want me to, I'll prove this to you, but what you have to do is take this point that it's approximately the same as f prime at c times the change, whoops, I'm going to do it this way, times the change in c. And this is the approximation. Not everything is going to be approximated, and we're going to be comparing. We're going to be comparing the change in y to dy, and that'll make more sense in a minute, where dy, where this is the approximation, and dy is the exact value. So this is where we're going. We're going to be going pretty soon to saying this, that the change in y is approximately equal to dy. Or the change in y is approximately equal to f prime at c, f prime at x times the change in x, dx. All right? And we're going to go through and compare these things, and it's going to make a lot more sense. But right now, I'm asking you to just take these as notes and say, okay, this is something I have to put into my head, because in the next video, we're going to be comparing these things, and we're going to be seeing that they do line up closely usually. But how closely, and what's our estimation of error? So this is just the basics. This is just kind of the notes. So I think usually my videos have a lot more explanation and definition to them. But in this case, I'm just trying to give you some notes and to ask you to buy this idea right here. So this is what I want you to buy. This is what I want you to put into your notes and to carry on. As this thing unfolds with differentials, this is going to be key. So this is absolutely key to what we're doing. So I promise I'd keep this video short. So it's short. Please watch the next one because it's going to add clarity, I promise.